Okay, I think we're ready to get started. After a couple late entries. Thanks everyone for joining today. So today we're going to be talking about something that doesn't really get a lot of love outside of compliance circles, and that is NIGO. So what does NIGO stand for? That's not in good order. And if you've ever had a financial process that you stall out because of a missing digit, mistyped number, an incorrect field in an address, then you've met NIGO before. The talk is about how we stopped fighting fires and started building some structure and fireproof walls. It's the story of how we moved from duct tape fixes, one-on-one implementations, to more of a scalable platform that keeps bad data out of our system and out of our customers' hands and their workflows. So this is where we're headed today. So first we're going to talk about, I'll set the stage with the problem, a little bit more details of what NIGO is, why it's more than just a typo issue, and how it can quietly ruin your day and that of your customers. Then I'll walk you through our early solution. Spoiler alert, it worked, until it actually didn't. We fixed NIGO and then accidentally created a bunch of new bottlenecks, so it's going to be an evolution. After that, we'll dig into how we flipped the model. We went from a centralized control to more of a developer-driven ecosystem. And then finally, we'll wrap up with kind of some key takeaways and lessons that we wish we'd known before diving into the platform design. All right, let's dive in. So before we kind of go into more details around the chaos, I want to just introduce myself a little bit more. So I'm David Gonzalez. I lead the Extend platform team at DocuSign. What that really means is I spend a lot of time thinking how to help developers move faster without breaking things. Our team builds the behind-the-scenes systems that make integrations possible at scale, securely, and not so soul-crushing to maintain. And we've lived this NIGO nightmare before, multiple times. And today, to share our bruises and few battle-tested patterns and how we went on one-off validation band-aids to an architecture that scales across our entire business and to our customers. Let's dig in. Okay, so first, before we get started is, what's the cost when a single digit is wrong in a bank account number or on a critical agreement? At first glance, it sounds like it's very small, right? It's just like a character, our classic off by one problem in engineering. But is it really that small, right? It's a tiny typo. The moment the check engine light comes on in your workflow, everything downstream can start sputtering. So what can that wrong digit cause? It could cause funds to bounce, contracts to fail compliance checks, your customers' trust to take a nosedive, and your team to drop everything they have to do to go fix it. This isn't a rare edge case either. Like when you think about high volume workflows, which is a lot of the fintech industries and our industries, it's not a matter of if bad data sneaks in, it's going to happen sooner or later. So this slide is the moment we realized if we wanted to stay on course, we needed to stop these issues at the very first mile marker, which is before they ever enter any sort of system. So let's define and point a finger at the villain in the story, which is NIGO. Not in good order, right? As many contracts and financial processes go about, required data is a must, right? Data entry, it's a must. Now, you can always say that data entry can come from different systems, but how does data get into the system to begin with, right? It could be web forms, it could be entered through external systems, API communications. So it can essentially happen all the time, right? Especially when you're handing data entry to consumers, that's when it could happen the most. The root cause, again, is just around the entry of data into different systems and then going downstream from there into other processes. Here, in this visual, we have a simple web form, which is taking data from a user and basically entering an address. Now, when you think about that, let's just take a supply chain, for example. When you think about supply chain, You grab that address, you give it to a supplier, then they give it to a shipping company, then they ship the package, and let's say instead of First Avenue East, you put First Avenue North. Now that package needs to go back. Now the person that has, which is your customer, doesn't have that package that they so much need. So as you can see, each one of these things is money. It's a cost. So the failures are just not discovered until it's way too late, right? Again, in automated systems, distributed systems, data keeps getting passed around, and we just assume that it's right sometimes. So the onus just keeps falling down the path, and then when you think about the impact, you had the shipping. In this example, you had the shipping, the supplier, the good could have gotten lost, insurance, just from a single package, right? So putting these numbers into what essentially caused the first roadblock is what happens with, what actually happens when NIGO data steps through, as I was describing, right? First, you get transaction failures. Workflows initiated with bad data eventually crash, whether it's a failed ACH transfer or misrouted document. Every failure has a cost, as I was mentioning. Second, the chaos introduces compliance risk, right? Unverified inputs often violate regulatory requirements or audit standards, especially in tightly governed industries like fintech. That opens the door to fines or failed audits. Finally, there's a drag on our respective teams, right? Resolving these issues means expensive manual rework, human intervention, support calls, customer calls, back and forth, emails, people really angry. It's slow, it's painful, and it's entirely avoidable. This is why we knew we had to stop this at the source. So, how did we fix this? To combat the chaos of NIGO, our first architectural intervention was the creation of a workflow validation gate. So a server-side mechanism designed to stop bad data at its point of origin. As you can see in this illustration, that's what we're calling the gate, right? It is essentially give a location where you can actually verify data. The idea is simple but powerful. Instead of waiting for data errors to manifest downstream, we place the gate directly in the workflow pipeline. If an input doesn't pass predefined validation checks, the gate blocks the process entirely. This ensures that only clean, verifiable data progresses through the system. This model gave us a programmatic enforcement point, right? A single reusable centralized control layer where all the data had to pass inspection. It was a huge step forward towards system resilience and drastically reduced the volume of downstream issues. But as we'll see soon, this solution actually had some limits on its own. So, in terms of requirements of this architecture, previously that was just a high-level sequence diagram of what the gate does. So in terms of requirements, we had to make it reusable. It needed to be decoupled because there were many points of data entry for our company, for example, at DocuSign. And we would have missed the mark if only fixed this for a single product. And we actually had some verifications in different systems, but reusable and decoupled. One of the second big requirements is that we needed to make it extendable to new use cases and integrations, right? We couldn't just build a verification for a single thing because then, again, it's not reusable. It conflicts with the first requirement that we just had. Last but not least, we actually need to make it open for developers because we at DocuSign were eager to start scaling these things and essentially enable our platform to be extended not just by us, but by others. And then that's where we got this beautiful plugin extension pattern. So to enforce the validation gate, we implemented a plugin extension pattern, which is just a modular architecture that allowed us to integrate third-party verifiers like LexisNexis, GUIACT, which are some bank account verifiers, and others into our workflows. Each plugin was isolated and handled a single type of data verification, whether it was bank account number, phone number, or email. The respective plugin was responsible for validating that input, that piece of input. And that gave us a high level of encapsulation and strong separation of concerns. Architecturally, this pattern offered high clarity and extensibility. Each verification logic lived in its own sandbox, reducing risk and complexity, and it was an elegant short-term solution, and it led to the immediate success in improving data quality. As you can see in this visual here, you can see the apps that are in the middle. Those are those basically those integrations to external providers. And then in our DocuSign products, we basically carved out what we call the extensions, where the UIs knew how to react, they knew how to control, they knew how to display those schemas, and then there is some sort of strategy between those and the back end. Now, victory, right? We killed it. It was a win. Our plugin strategy was a game changer. Almost overnight, we actually gave NIGO rates actually declined for customers. Addresses, emails, and phone numbers were lowering. The NIGO was lowering drastically. And then this momentum sparked an innovation boom. New verification ideas poured in. Driver's licenses, tax IDs, business licenses, KYB, KYC. All of these things started to grow. And because of every win proved, we could raise data quality without slowing the customer journey. Our catalog verified data types and the provider integrators didn't really just grow, it kind of snowballed. Best of all, the impact was felt everywhere, from our e-signature products to our workflow products to our APIs. Teams stitched our verifications into their flows, and it shipped faster with fewer support calls. We turned data integrity from a liability into a competitive advantage. Now, was it all wins? We thought so at the very beginning, right? We were, as I was describing, everything was going in the trending upwards, more demand, more use cases, lower NIGO rates. And that's when we ran into our second roadblock. So the plugin pattern gave us early wins, but it introduced a new architectural and organizational bottleneck. We had effectively centralized all verification logic inside a single platform team. This meant that we were the gatekeepers, and we is anybody at DocuSign at that point of time. And every new request essentially had to go through code changes, right? So anything like that is not really decoupled, but it was extensible. But it put us in the driver's seat of having to control the supply and demand. So as the queue kept growing, as for tax ID verifications, professional license lookups, regional specific ID checks, they all demanded time and a little bit of expertise. The model simply didn't scale. We were spending more time building and maintaining plugins and enabling the business. And this became a critical barrier to innovation. Our next step required a slight rethink, one that would essentially invert control and get us out of the way and push verification logic closer to the teams that really own the data. They know the data. So why don't they just own the definition of it and the strategies around it? So instead of us building that led us to this next question, which is, instead of us building every integration, what if we can empower developers to teach our platform how to verify their data? That led to our aha moment. It was a realization that control needed to be inverted. Instead of building every verifier ourselves, we needed to give all of our developers, those closest to the data, the power to define their data, and that can also be verified with the strategies and the methods that they knew best. This pivot marked the next major architectural and philosophical shift for at least our team. Our platform team will no longer be the implementers, but the enablers. We'd provide the interfaces, the frameworks, and the guarantees as we'd previously done, but now let any developer plug in their own logic and their own data types. This moment became the genesis of our move to what we call the strategy pattern. So what needed to change? So this is the previous architectural diagram about what I was showing earlier. Now we've basically added these two new capabilities that I'm going to show up in a sec, which are about exposing strategies and also exposing data types to the developer, something that wasn't really previously possible. So in terms of evolution, we gave the developers the power to give us the data types that they needed to verify and also give them the ability to implement the verification of that data themselves and give it to our platform. Now, what was traditionally a data-specific extension, which was just, again, a verification of a specific type, now became just a generic verification extension that was that can pivot based on the specific data types configured by the customer, and then that were provided by our suite. So this led to both further generics within our platform and to each of our DocuSign products. And it was what once went from, again, from a data type specific extension was now a generic verification extension. So what does this mean in code? So here I provide a little visual between the before and after. So there are essentially two types of personas, and let's go from on the left-hand side first. So before this evolution, all interfaces were essentially created by us, and they were very specific. For address verification, there was an input type, output type. For SSN, there was an input type, output type, et cetera, and that's kind of where we were in the way. Then on the developer just implemented that verification. So if it was an integration with USPS, they would make the API call to USPS, handle those inputs, translate it to our outputs, and then give that result back to us. It gave us standardization, but again, it put us in the way. On this, the after was more that we moved the inputs and the outputs. Sorry, we moved, DocuSign then just moved to generics on the strategy, which was the verification, that's the strategy, and then on the inputs and the outputs, and that's it. So it generics with delegates, and then it put the power into the developer to define what is the data that they wanted to import and export, and then how they wanted to verify it. So this brought us essentially to the new world. In today's architecture, which was kind of our, the goals that we wanted to accomplish, we got to a scalable verification ecosystem. So now we operate a platform that enables internal and external teams to create, register, and maintain both their verification strategies and the data that they need verified. Using our interface and declarative-driven strategy pattern, any team can define how to verify their unique data types, and then the platform itself remains untouched. It's just a stable core designed for extensibility. Then from there, we've decoupled growth from centralized control. This has created true self-service extensibility. So verification logic lives with the teams who understand their data best, and our platform just orchestrates it, ensuring whatever flows through our system is verified, reliable, and in good order. We've eliminated the NIGO problem at its source and at scale. So from here, what did we learn, right? In terms of the journey that our teams took, first we saw quick success by applying the plugin pattern. This helped us patch critical data quality issues and stabilize our workflows with trusted verifiers. However, at the same time, this success created some scaling bottlenecks for all of us. The plugin approach centralized too much responsibility to our platform teams, and the model didn't support the growing needs of our business. The breakthrough came when we evolved that to a strategy pattern. By inverting control and allowing developers to define their own verification strategies, we eliminated our team as the bottleneck. It was a strategic architectural shift that transformed verification from a service to a platform. So the key, something that I wanted to touch up on in terms of that journey, verification was just one of the many use cases that the platform allowed. When you think about just APIs in general obviously have the ability to validate any input and output. It could encapsulate file streaming. It could encapsulate importing of files, writing of data, reading of data, et cetera. So it did really, the plugin pattern actually was the first stepping stone in us finding out, A, how do we scale to the demands of our customers? How do we meet them where they are to connect with their data? And then for the verification use cases, how do we invert control and give more power to the developer so that then we scale at the same rate that they do? So in terms of the most critical architectural lessons that I was hoping to share with the group here, the The first one is around starting with what works, right? Start simple, then evolve. I think that's been a common theme in some of the chats that I've actually been a part of here in the sessions, and it is tried and true. We could have theoretically started in the first go, but going back to the, it's not about the destination, it's about the journey, how you get there. We wouldn't have known the problems we would have known unless we went through them ourselves. So that part really stuck with me in terms of being able to share that. The plugin pattern was the great initial choice. It gave us traction fast. But we recognize that when its limitations appear, your system will need to evolve, as others do. The second key takeaway is to establish architectural control points, like validation gates early in the process. They help enforce consistency and catch errors at the boundary. These validation gates, at least for us, it allowed us to plug in, when you do this architecturally, you create integration patterns and you create platform layers to your company as a whole. That was one of the main benefits for us, because by us offering verification wholesale and any type of verification, now every team at least within our company at DocuSign, they wanted this, right? If you offer them the ability to stop corrupt data for entry in their system, it's the most appealing thing that anybody would want. So by becoming an architectural control point, it became really easy to kind of share these wins with the rest of our organizations and the rest of our engineering teams. Know when to invert control. This is easier said than done. Again, going back to the kind of the evolution of kind of where we started and where we ended up, I don't think we could have started with inversion of control, because there is exposing data types in general to users is tricky. There's schematization languages, DSLs, domain-specific languages. So it wasn't really that easy, but it was a natural evolution when the time came. So inversion of control definitely helped us a lot. Another point here is we actually started with inversion of control. So we started, since we wanted to target developers from the beginning, my previous code example shared that, where the developer still can extend locations at DocuSign, right? So you can still verify addresses, et cetera. So there was a power to the developer for them to give that already. So again, inversion control when needed, and remove bottlenecks and just become enablers, which is the other tricky part. Last but not least, interfaces unlock scale. And this is it's basically just a coding principle of ours, right? When you think about DI, dependency injection, when you think about polymorphism, it's all around interfaces, right? And interfaces, at least at DocuSign, they gave us that scale. It allowed the teams to even propose actually changes. And actually, as we started scaling from creating these extensions ourselves and these data types ourselves, teams came with more ideas, more use cases themselves, and it was all centered around interfaces. And interfaces, again, are just schemas, structured data, so to say. So these takeaways, at least to us, we believe that it applies to any platform-oriented architecture where like scale, flexibility, and data correctness are the top priorities. When you think about fintech is centered around these core principles, especially bank transactions, credit card transactions. It's all around the data correctness and transaction at scale. So having these key architectural takeaways were some of the key moments for us, and they were great moments to share to the rest of the audiences. So with that said, I wanted to give thanks, and I wanted to see if there's any questions in the audience.
So I'm not too familiar with the other products besides signing documents.
Mm-hmm.
Touched you guys at some point, but for my use case, I'm seeing this as I'm a little farther
Mm-hmm.
but the customers filling out information, their whole tech stack, and then filing this to us. Are you guys in a similar area, like in terms of a product's workflow, and how did like exposing validators? It helps your data to be
Mm-hmm.
better, but if I'm the front end product guy, I don't know if validating this in our back end, it probably should get me upset if it didn't work.
Yeah. So let me think about that use case a little bit better. So is the question is your question around? Let's go back to the use case again.
So just to basically say, like, do you see this validation being used in all parts of a workflow?
Oh, yeah, yeah, yeah. So it definitely is more prevalent in some locations. Data entry is definitely one of them. So anything that is either a web form, is read from another system, or I think those are the primary two. So that's the key locations that I would say that this, at least the verification framework is involved the most in. And within DocuSign, there is, as you mentioned, the signature product. There are other products that do the same thing, just in different flavors. And that's where we saw the highest uptick in terms of onboarding. And then the other key thing, honestly, is regionality. So as we started shipping to different regions, the verification needs of each one of these changed. So depending on the industry, that would be one of the things that drive the usage the most. We would see that we would require more verification steps in different locations in a workflow. So not just web form entry. You would need it to verify the identity of the recipient. You would need it to verify the identity of the signer when they open the form. That's even before web form entry. So it actually just exposed a bunch of new locations that we didn't really think of previously. Going back to that email use case, that one's a really interesting one because eSign previously, for example, that was one of our products, eSignature, which is the sending of envelopes for signature. One of the first things that it does is just you add a recipient. But what happens if the email is wrong, or the recipient name is wrong, right? It can't route. It probably won't route, or it just won't get to the destination. So in its simplest form, we saw that just adding an address book was a way to add verified data to a customer, and it wasn't really heavy-handed. It's just the ability to connect to your data, to an address book that you provide, because you know your data, and that's where your data is. So verification also, it wasn't only the ability to verify data with the government, right, that they have these sources of truth. It was also you being able to pull in the data that you think is verified because it's in your database. So that was the other, some of those use cases that we wouldn't have known without this type of system. Yeah. Any other questions? Please.
What were the main challenges when implementing the plugin architecture? Especially when opening data up to users out there.
Yeah.
Wild.
Yeah.
That you faced, and what did you learn? What were the main things you learned from that process?
So yeah, the question is, what were some of the major challenges that we discovered as we just introduced the solution to our first roadblock, which is just the plugin pattern. So let me think about some of them. So I definitely think that one of the plugins themselves presented a problem, which is how did we know that we were creating the right plugins? Actually, I've got even a better one. That was a challenge. The other challenge was versioning of plugins. So when you are talking about just APIs in general, our natural inclination is to add optionality everywhere. right? It's just like, hey, we have a new API version. Let's add a bunch of optional parameters. We're deprecating these request parameters. Let's put them at optional next, and then we'll remove them in a v3 API. So versioning to this day is actually our hardest problem because we want to give backwards compatibility. We don't want to push conditional optionality and handling to our consumers. So imagine if, so there's basically two major personas. It's DocuSign products, which react to the data, and then app developers, which are creating these validate verification systems in the back end. If both systems have to deal with different versions of schemas, and those schemas have optional parameters, you know, it's a truth table, right? It's like, it's gonna grow exponentially in complexity. That to this day is a complexity, but at least in the verification world where we gave the types to the developer, it's helped us a little bit because we just have to create a surface that handles data. If the data is V1, V2, V3, we don't, like DocuSign isn't in the way, but the onus kind of then falls onto the developer that they have to own they have to manage those versions on their own. So that was another, that was around plugin versions. As you add new functionality to applications, let's say if you created a strategy pattern or a strategy solution for address, and now you wanted to add SSN for your same integration. Because let's say you integrated with, again, the example that I gave earlier, which was the government, and the government probably validates a bunch of other things. That was another interesting thing because we wanted to give customers the ability to update their apps without breaking their existing workflows, right? So it's almost like you can give them the opt-in capability without breaking any of their integrations. That's also tricky. Last but not least, authorization and authentication. One of the hardest things to do in all these types of distributed systems because every integration has their different implementation of the OAuth spec. They have their different, some have PKCS, others have SHA restrictions, byte length, key size, all these fun things. And although we did go with an in-house solution that we built, doing that securely was another challenge we did overcome, but it's ongoing because the more integrations you build, the more complex it gets. Yeah, good question. Okay, I have a couple more minutes. Anybody else? Okay, last session. You made it. Thanks again for being such a good crowd. Oh, one last thing I wanted to say. Our developer relations team is here. They're amazing. They create content constantly about everything that I described, about different verification patterns, things that we call connected data, which was those new strategy patterns that I shared. The resources are here. The link is amazing. Paige is one of those talented developer relations and developer content team. So please check out our tools, our developer tools. You can build outside-in integrations to serve your customers with a lot of the tools that we have, and you can create new apps in our ecosystem. It's just an app store, so you can publish new apps, new integrations, and it's completely open, free. So be curious and let us know how we can help. Thank you.